Hey there everyone, happy March break! The information we have right now is that this radius of this circle is 8 centimeters. We're trying to find the area of this shaded area that is pink. We know that this is a equilateral hexagon. And yeah, let's get solving. So the first thing we're going to do is, let's just mark out this so that it's all equilateral. And if this is an equilateral hexagon, then this angle, the interior angle of any equilateral hexagon, is always 120 degrees, which means if we use OAT like this, opposite angle theorem, this angle is also 120 degrees, and that leaves this angle and this angle to be 60 degrees each. Right, because 360, the circle, minus 120 equals 120, and you divide that by 2, 60 degrees on each. Okay, now if this is 60 degrees, and we know that these sides are equal, then this is also 60 degrees. And if that's 60 degrees, then by using the sum of the angles in a triangle, we know that this is also 60 degrees. And that means that this is an equilateral triangle. And so now we know that we have 1, 2, 3, 4, 5, 6 equilateral triangles and an equilateral hexagon. Now the next thing we're going to do is we are going to draw a line, the radius. It's from the center of the circle to the edge of the circle, the circumference. And we know that this line is 8 centimeters, the radius. Now let's draw 2 more guidelines, like so. Okay, now let's draw the rest of the guidelines in, so that we're filling this whole hexagon with congruent triangles. And the way we know that these are all congruent triangles is because this is an equilateral hexagon. Since they're all congruent, then we know that each angle has to be 60 degrees, and 60 degrees here, and 60 degrees here. So they are all equilateral. Okay, now that we know this is 60 degrees, and we already know that this one is also 60 degrees, then we know this is all 60 degrees, this is all 60 degrees. Then we know that since they share this side, these 2 triangles are also congruent. And that means that we have 12 congruent triangles now. Congruent equilateral triangles. Now that we know that, let's go to solving the side we need. So let's pull out one of these triangles here. This is what it looks like at the moment. Right, something like that. We know that this is 60 degrees. We know that this is a right angle, so that leaves this with 30 degrees. And now we have our typical, wonderful 30, 60, 90 triangle. So what that means basically is that the ratio of the sides is 1 to root 3. Now let's take a look at this radius line here. Since this radius is 8 centimeters and, this kind of bisects it, then this is 4 centimeters each. So if we know that this is actually 4 centimeters, then since that's root 3, then this down here would be 4 over root 3. So this to this is 4 over root 3. So that means we can now find the area of each equilateral triangle. So we would do 4 over root 3, since that's only half of the base. Let's do the full base. So multiply that by 2, and then multiply that by the height, which is 4. And then we can divide that all by 2 because it's a triangle. So the area of the triangle is equal to that. If you punch it into the handy-dandy calculator, you will end up with 16 root 3 over 3. And now, since we have 12 of these triangles, if we take the area of each equilateral triangle, multiply that by 12 of them, we will end up with 64 root 3 centimeters squared. And there you have it. That's our answer, 64 root 3 centimeters squared, and that's the area of the shaded region, the 6-pointed star. And that's how you solve the 6-pointed star question. Thank you so much for watching, and have a wonderful rest of the March break. Thank you.